Another project I have for a friend, again, is a Fehlmann table. And this is a high-end Swiss XY table with everything, I mean, accurate, nicely made. And so it's a little bit worn, not much. And then this guy. Used as a drill press table, I think. More drilling into the table than than for secure fastening of whatever workpiece. And here a little bit worn on the waist. But more molested than worn, I'd say. I'm not sure if we are going to do anything with those holes. At least I'm sure I'm not going to do anything with it personally. But if something should be done, I guess it should be welded up and remachined. But I think the owner has plans to just cover it with a plate anyhow. So, and of course, as always, Gibbs should be tested. I guess they are quite bent. A little bit high in the middle, but this was worse. So you can see that if you view that from the side, really, or at least I can. The table is out for grinding a little bit on the top. But now I'll just check the flatness on this. And so setting 0 over here at the far end, we can move in. And it follows closely, but will detect something like 1/100th of a millimeter wear. And the same repeats on the other side. So not much. And that is the entry point. And let's check this also. 0 there. And possibly 1/100th of a millimeter high there. Of course, that's how it should be. I mean, like a reference, everything ground together and no surprises. So if we set then 0 there and 0 here, we have +1 here. So I would also suspect that the dovetails were a little bit like so, meaning a little bit worn on the inside, which we will prove, of course, with the measurements. But now, having proven it to the plate here, I can at least take down the top here. So I will then step scrape it, maybe divide it into 4 equal steps, which means that I'll take this once, twice, and 3 times, and leave this unscathed. So I will use the biax. So the first thing I'll do, I'll just ensure that the blade is sharp. So I select the slow speed on the grinder. It's already set at an angle. And just snug it up here. So you see there's a rubber gasket. You don't need to tighten it too much. Well, the correct way probably. So, and then select the speed. Okay, and also the stroke. I'll give it a little bit more. And I don't want to hit the corner there, so I'll take that from the other side. I'll start here and take this part once. I'll turn. So I cover this also, and then again down here. This way I've taken it once, twice and 3 times. I'll repeat that small area there afterwards. And then I'll do that afterwards, but first I'll just cover the inside. I think I can do that with the same technique from here, although I might be arrested by that. So now move it around, take that really twice. So just a couple of cycles made it flat, even reduced a little bit low here where it used to be high, so it doesn't take much. So now we'll blue it up to see, and then take it from there, and then I'm satisfied that this is flat to the plate here, and that I can use this as a reference to build up. This is the bottom piece, so to speak. And the real tricky part of this piece is, of course, the protrusion here. Makes it impossible just to print it directly down like this. So instead I have to go 2 ways, this way, covering most of the ways, like so. And then the outer edges here also separately. At least that's what I think. So first most of the way, and then separately on the other side. So we can see here already where to take off, and then important now is to keep it everything flat to the piece there. And then I'll take the majority of the plate like this, or the 2 ways on the plate, and then afterwards these can be taken individually. Really then satisfy that this part is all flat, and I can bridge over to cover this also. Stupid design here. So then the process I will follow is then to alternate between then the scraping and consequent stoning, and then just checking the corners that I'm flat, like so, so I don't develop any misses. You see I'm high here, so, but that will be proven when I turn the plate around to cover like so, this way. I will be able to prove it within here, and then of course leaving that necessitates that I use a straight edge to prove each one and scrape that equal amount. So having good coverage. I will then know that these are flat to the plate and to one another. So I will then, for simplicity, I could of course just flip it around and do like so. I do, however, prefer to use a straight edge, and I think the Richard King design is very nice because it has a certain balance and feel to it. So it's a compromise between, I guess, the weight, and also you are allowed to hold like this, which this grip is, well, I think it's preferable to others. You can feel the hinge points and everything sort of comes together. So, okay. And also can be placed, actually, if you mill it flat there, like so. So I think actually this has a lot to go for it, this design. I like it. Of course, it's made by a pro. Just put his experience into it. So it's no wonder really that it functions good. In my opinion, you get a much better feel with handling the straight edge, as it almost should be done, instead of inverting the casting, the heavier casting. See, shallow here. Of course, this measures, I mean, you're able to measure in thousands of millimeters here. So, it's no wonder that you get this sort of print. I can feel it is hinging a little bit here in the middle. I managed to find a setup I was pleased with, like this, both to scrape and to measure. So, now we'll turn to take the other part. And I know that I'm going that direction. I left out that over there. We'll take that too. This will give it the checkerboard pattern. Getting closer, at least from the point of coverage. Still have a little bit here. We go down here. As you can see, should be able to see, it's half a hundredths. And run it up. It fluctuates 1/100th of a millimeter, which is okay. Now I want to measure the dovetails, so I'll use this one that enters this dovetail, and I know it's flat on top here, so I can measure then with reference to one dovetail and to the other. I don't know which of them is correct, but we'll soon see that with the straight edge here, I guess. If both are bowed, then, well, then we know that too. This looks more worn than the other, so I'll risk using this one to measure. So So my test setup for measuring the dovetail confirmed that this is the least worn, but they are really almost negligible, where not anything to do anything with, I think. Maybe half a hundredths in the middle. From that side to that side, could be here of course also. So I'll test that with the straight edge. I'm a firm believer in making it as convenient as possible, as comfortable as possible, because it's a kind of a feel thing. I'll clamp the casting really hard either. I just have snugged it up, and then instead of fighting gravity, I will use this so that it falls in place. Would be maybe even better if I had it an angle so it was directly horizontal. I think I can do it like this, and then be able to get a feel there. I think it's a little bit high in the middle on this side. Not by much, but a little bit. Can you see? Not much, but maybe a tad. Having glued up again. And this is where I think this design is really superior also. And this is the opposite. As far as I will take one more measurement. See? It's a little bit more worn. The clear stripes, also wear stripes. I'll take one measurement more to verify before I start. I think I'll go for the hand scraper. Could do it from this side, of course, but again, wanting to have it as comfortable as possible, I will turn it around. Didn't take much really to get that to bear, and just use the hand scraper. Becoming a little bit high in the middle actually. Still a bit high in the middle. Just a touch. So here we have the Fehlmann table, ground on top. Although these holes aren't mended, they shall be covered with a plate here. Ground on top and ground underneath here, and then scraped. Scraped all over, and then it is as good as possible, or almost 0, 0. So if we zero the indicator here, I can move anywhere on the plate and it remains 0, and also here going over it remains 0. There is no backlash in the scales here at all, actually, and this wasn't much worn really. I just scraped this for like an eye wash effect here. But this is a typical high-end table, really, so to be expected. Everything is square and accurate.